Hey everyone, and welcome to the next installment in the series about supercharging your Kubernetes deployments with Flux v2 and GitHub. And this part looks at monitoring and alerting. Now let's look at what we did in the previous videos. In the first video, we looked at what is Flux v2 and we installed the CLI and bootstrapped our cluster from a Git repository. Then we took a small detour in the second video and we looked at kustomize, because kustomize is heavily used by Flux to deploy YAML manifests to your cluster. In the third video, we created sources or a source to a Git repository with YAML files, and then we deployed two kustomizations from those YAML files. And now we end up at the monitoring and alerting part, where I want to see what Flux v2 is doing, and I also want to be alerted about changes to my system. And I will use Teams to show that. You can of course use Slack and other systems as well. Before we get started though, let's look at what we have. We have a Git repo called Scratch Infra, and that's the Git repo that I bootstrapped my AKS cluster with, so a Kubernetes cluster in Azure. This Scratch Infra repository contains all sorts of custom resources. Secondly, I have a real-time app infra repo that contains the YAML files that I'd like to deploy, and these YAML files use kustomize with overlays and a base. That was all explained in the previous videos. So if you look at what we have a source pointing to this one, and we have two kustomizations that deploy the dev and the production environment. And what is actually deployed? Well, we deploy an app, which is a real-time app, as I call it. It's a simple app written in Go. And there's also a GitHub action that builds and pushes a new container image when the source changes. And depending on how we make the change, we modify the image in either the dev or the PRD overlay. That was also explained in the previous video. Now, let's look at what we have to do monitoring. We use the same bootstrap repository. So in this case, Scratch Infra, and I'm going to add components. I'm going to add extra files to this repo that Flux can then use to install the monitoring components. Now, what the people of Weaveworks have done is they have provided a Git repo, Flux 2 here, a folder called Flux 2, and that one contains source files, YAML files that deploy Grafana and Prometheus. Now, of course, if you have your own Grafana and Prometheus configurations already, you can use those to monitor Flux v2. But if you don't have anything else, you can actually just add a monitoring source to this Git repo and then add a monitoring customization that deploys and manifests inside this repo in manifest/monitoring. We'll see how that works in a moment. Do remember, if I'm not mistaken, that the Prometheus installation only keeps metrics for around 2 hours or something like that. Now, when you have the installation done, of course, you'll get Grafana dashboards out of the box. They look a little bit like this, and I'll show you in a moment how we actually get to those Grafana dashboards. Let's add the monitoring source first. So as you've seen in the previous video, that's just Flux create source based on Git. We call the source monitoring, and we point to the repository that Flux 2 provides to install the Grafana components. Just as before, realize that I'm in my Scratch Infra repo on my local system, and I export the results of Flux create to a YAML file in this repo in the app cluster folder. So if I press enter here, this just generates a file. Let's just go in the CD in the app cluster. Let's do ls here and do a cat on the monitor source. And as you'll see here, this is just a Git repository source, which refers to this URL, and the branch is main. By the way, as you can also see here, it checks for changes every 30 minutes. And there's no need to check here every minute if something has changed within this environment, because it will not change that much. Great, that is the first thing we have to do, create the source. The second thing we have to do is to create our customization, because remember, customizations actually deploy the YAML files. We call the customization monitoring. We use the source monitoring that we just created, and the path where the YAML files are that deploy Prometheus and Grafana are in this folder. Of course, it pays off to also have health checks here. And when these YAML files deploy Prometheus and Grafana, we are going to check in the namespace Flux system if indeed the deployment Prometheus and Grafana are healthy. And just like before, we're going to export the results of this Flux create command to a YAML file. Let's press enter. Let's go into app cluster, clear this out, and then do a cat of the monitor file, in this case the customization. And of course, this reflects what we used in the command line. And it's a customization just like yesterday or in the previous video where we created customizations to deploy our application. This is just another application, but an application which is running within the Flux system namespace that monitors the whole Flux v2 environment. I just committed the source and customization to my local Git repository and then pushed that to the GitHub repo. That means that Flux v2 should see these new additions, should see this extra customization. And as you can see in this list with the Flux get customizations command, I can see monitoring has been added and the ready state is true. That also means that Grafana and Prometheus should be up and running on my system. Let's see if that is really the case. Let's clear this out and let's do a port forward to service Grafana on port 3000. We can do that here, and then we'll check in the browser what we can see there. Here we are in Grafana, where you can see that there are two dashboards, the Flux cluster stats and the toolkit control plane. Let's just look at Flux cluster stats. What do you see here? I'm not going to go on all the blocks and explain what they are. But for example, what is interesting is to indeed see, hey, I have a bunch of customizations. What's the status of these customizations, for instance? And you can see that here. I also have a bunch of sources. What's the status of these sources? What might also be interesting is that you also see how long the reconciliations are taken. In this case here, it's not surprising that the Flux system reconciliation takes longer because there's much more components in the YAML files for Flux system. So this is the first dashboard. If we go to the other dashboard, which is the GitOps toolkit control plane, I will just scroll through and show you what is in there. As you can see, this is more about what is the memory consumed, how many API requests are being done. So these kinds of metrics can be seen here. And for instance, the CPU usage and memory usage per controller is listed there. So for the Helm controller, customized controller, and so forth, they're split up per controller. I'll just scroll down a bit so you can see what the rest of the metrics and graphs look like. Of course, my Helm charts or the Helm graphs are empty because I didn't add any Helm sources and Helm charts yet. Now it's time we look at how to do alerting. So remember, we're starting from the same bootstrap repository called Scratch Infra, and now we have to configure that to do alerting, in this case to Teams. As I said, Slack and so on is also supported. What I would do here, or what I will do in this demonstration, is I will add a secret to my Kubernetes configuration that contains the Teams URL I have to connect to. That will typically start with HTTPS and then Outlook. Next, we have to add a Teams provider, and that will reference the Teams URL secret that I created before. And then we add an alert. Of course, the alert will reference the Teams provider. And in the alert, we define the event sources. So what kinds of events we are interested in. And then you will get in this case in Teams in a channel, you will get these kind of messages. Let's see how to configure this. To create the notifications, I created the provider and the notification YAML directly in the repo, just to show that you don't always have to use the Flux command and then export it to your repo. You can of course just add a YAML directly to it. So I first created a Teams provider.yaml file that basically sets up the Teams provider. It's of type MS Teams. The channel in Teams is called Flux v2. So that of course needs to match the channel name in your Teams environment. And as I explained earlier, I created a secret called Teams URL that creates the Teams URL that I want to send notifications to. That's first of all the provider. Secondly, I want to know what notifications that this provider will send or receive. In this case, I created an alert. The alert is called real-time app, although that's not really the correct name, this one over here, because as you can see, what I'm saying here is I want mainly information, so not just errors and so on. I want information about what is happening, and I want this for all my Git repositories and for all my customizations. So I will basically also get information about my monitoring customization and the Flux system customization. So it's not just about the real-time app. Of course, these ones already were committed to my repo on GitHub. So let's check out what Flux now knows about this. When you watch the command flux get alert providers, after a while, so after committing the alert provider YAML to your Bootstrap repo, you will see that indeed the Teams provider is listed and that it is initialized. And when you do the same things for the alerts, so flux get alerts, you'll see that the incorrectly named real-time app alert has been initialized as well, and that its state is true or ready. I just made a change to the Flux system repository, and as you can see, I now get alerts in Teams that state that a revision was fetched and also what was configured in that revision. Of course, in this case, it's quite a lot because it's about Flux system and there's quite a lot of components in there. Yeah, so that concludes our configuration of alerts to Teams. So we've seen all the steps now and we finished up with monitoring and alerting, but of course we still didn't touch one very important aspect, and that is how do we work with Helm charts here? Because you might not want to use just plain YAML files with customizations. Maybe you standardize on using Helm and you want to deploy your applications using Helm charts. Of course, Flux supports this, and in an upcoming video, we'll take a look at that. So hope to see you then. Stay tuned. Bye bye.